Thank you for the opportunity of giving this speech in this international conference. Today we are going to speak about sequence stratigraphy with a special focus on the sequence stratigraphy of lacustrine systems. This is the flow line we are going to follow during this presentation. We are going to start with the objectives now. The schedule today we are going to start discussing some difference about between marine and lacustrine sequence stratigraphy. Then we are going to discuss the main controls in lacustrine sequence stratigraphy, and finally we are going into the field to see some examples of how these lacustrine sequences looks like in an example from Argentina, the Rayoso Formation in the Neuquén Basin, and also in the Ordos Basin, the Yanshan, the Triassic Yanshan Formation in China. So, going inside some concepts about sequence stratigraphy, I would like to say that, for example, this is more or less some general concepts about the sequence stratigraphy, the definition of sequence stratigraphy, and the definition of the positional sequences in general don't refer on sea level changes. The only strong point of sequence stratigraphy about the control of sea level in the development of the positional sequences is when we talk about the accommodation space. As you know, the accommodation space is very important because the accommodation space defines the space available for the sediments to accumulate. So basically, if we increase the accommodation space, you are going to have a transgression. And if you decrease the accommodation space, basically you are going to have a sequence boundary. In sequence stratigraphy, usually people relate the accommodation space with variations in sea level, eustatic or also some relative variation in sea level. In static sea level, usually you have different kind of cycles of different frequencies from the first to fifth cycles, but all these cycles we have in the marine setting are absolutely different respect to the rates of change we have in lake levels, because lake level can be highly fluctuating. Lake levels can fluctuate because the lake level, especially in closed lakes, the lake level depends on how much water we enter in the basin, how much water we enter in the lake. So if we introduce a lot of water with sediment into a lake, you are going to have a transgression. At the same time, you are going to have sedimentation. So this make lacustrine basin much more complicated in terms of sequence stratigraphy. For example, another important difference is that in marine settings, sequence stratigraphy assumes that most sediments are supplied during the low stand. So during the low stand, the sea level fall and sediments, clastic sediments, are directly transferred into the basin floor fans. In contrast, in lacustrine setting, most sediment supply happen during the transgression. This is because during this time we introduce a huge amount of water and sediment into a lake. We are going to have deposit, but at the same time the lake level is going to rise. So we are going to have, at the same time we have accumulation, we are going to have a transgression. And in contrast, when we stop the sediment and water supply, usually in many lakes you are going to into a restrict condition of the lake, and we can have also in some situation very extended delta plains or soil areas, and also saline lakes. So taking into a close look about all the factors that control the development of sequences in a lacustrine setting, we had to talk about this sediment and water supply. We just talked about this. It's very important because it's the control the amount of sediment and water that enter in the lake. So if you introduce more water and sediment, the lake is going to rise. Additionally, we have the groundwater supply. Groundwater supply is very important because it's going to provide, in some cases, some salts that contribute to create a saline lake during periods of very high evaporation. On the other side, we have subsidence that create this space to accumulate the sediment, and at the end we have the lake spill point. The lake spill point is very important because control the maximal possible lake level. If lake level reach the spill point, we are going into an overfilled lake, and the lake level in some cases can be constant, in contrast with what happened in underfilled lake, in which the lake level highly fluctuates. So going inside the different kind of lakes we have in nature is a very interesting classification by Carroll and Bohacs in 1999. Carroll and Bohac recognized three kind of different lake systems. When they contrast on one side the sediment and water supply, and in the other side the potential accommodation space. So we have, in this context, we have underfilled lake, in which you have much more subsidence than sediment and water supply. Bohac called this underfilled lakes, like usually he said these are saline lakes. And then you have the situation in which the lake level fluctuates, and in some situation, in some position, the lake level reach the spill point, so it's going into an underfill and overfill condition. And at the end we have this kind of lakes in which the volume of water that enter in the lake is too much, so the lake level remains almost constant, and sediment supply is accumulated from the lateral to the supply areas. So if we analyze this kind of situation, of course we have underfilled lake, which are basically closed lakes with the lake level below the spill point. This transition or balanced lake situation, and finally open lakes in which the lake level is almost constant and controlled by the spill point. Many basins, many lacustrine basins, start with underfill condition and goes into an overfill condition during the last stages of lake development. This condition on underfill, balance fill, and overfill also control the kind of stacking pattern you have in the infilling of a lacustrine basin. For example, if we are in an underfilled lake, every time you introduce sediment, we introduce water, and consequently at the same time we accumulate the deposit, we are going to have a transgression. And at the end, this is why we have here these fining upward sequences. And on top, when the evaporation, and we decrease the water supply, the evaporation decrease the lake level, you can go into a system dominated by subaerial exposure, by very extended delta plains or soils, red beds. In this case, you have this transgressive system track and regressive system track, typical of delta system. In this situation, in balanced field, you have one period in which the lake is in underfield condition and another period in which the lake is in overfield condition. So the typical stacking pattern of these small sequences is a fining upward initial sequence and then a quartering upward succession when the lake level reach the spill point. And finally, in overfield lake, it's very interesting because most of the small sequences will be quartering upward. This is because the lake level remain constant and the incorporation of more water don't create more accommodation space. So the sediment are forced to prograde. So we are going to have clinoforms in this situation. So now we are going to see some examples of lacustrine basins from Argentina and from China. At the first time, I would like to introduce some concerns about the Rayoso Formation. Rayoso Formation is a lacustrine deposit accumulated during the early Cretaceous in South America, in the Neuquén Basin. The Neuquén Basin is located in the west center side of Argentina, and these lacustrine deposits are up to, in some places, more than 1,000 meters thick. And we can recognize here three sequences. We call these sequences R1, R2, and R3. These sequences has two intervals, the transgressive system track and the regressive system track. As you can see here, main deposits are accumulated during the transgressive system track, in which you have a brackish lake. During the regressive system track, the lake restrict, and so it go into a saline lake. This is a cartoon showing the evolution of an underfield lake. As you can see here, the lake, when the lake receive water and sediment, at the same time you have deposition, you have a transgression. So you are going to have this fining upward. At the end, when you stop the water and sediment supply, all the system, you are going to have a regression. You are going to have a lake level fall. So all these marginal areas will be, in this case, and we are going to have soils. In the case of the Rayoso Formation, you are going into a saline lake because a lot of salts were supplied from the groundwater. This is more or less the depositional condition for the Rayoso Formation. Here you have the condition during the transgressive system track, in which you introduce sediment and water, and you have this brackish lake in which the lake level rise. And this is another situation in which you decrease, dramatically decrease the supply of water and sediment, and consequently you go into a saline lake with a lot of evaporation and supply of salt from the groundwater. So this creates those two different kind of system track. Regressive system track with stromatolites, with alide, with the gypsum, and transgressive system track with this clastic bed with fine-grained sandstone with fining outward, forming these fining outward sequences accumulated in a brackish lake. So let's go to see some outcrops. This is a general view of the Rayoso Formation. This is the initial sequence, the saline lake, the R1, and then this is part of the R2, and then this is the beginning of the R3. Well, you are going into to see some examples here. We are going to fly into this position, and just to see some examples of these deposits. Here in this situation, you can see a very beautiful example of this shale with the stromatolites. These stromatolites are the consequence of a hypersaline condition you have in the Rayoso Formation. Additionally, if you go a little upward here, we can see a very beautiful pseudomorph of halite. In this case, you have halite crystals, and this halite crystal we are replaced, we are dissolved, and then filled by very fine grained sandstone by fallout. So here you can see the typical shape of this halite crystal, which suggests probably a hypersaline condition. If you go upward, then you are going to see these fine-grained sandstones, these deposits, accumulated during the lake dilution and related to the incorporation of huge volume of sediment and also water. In this interval, it's not possible to find stromatolites. It's not possible to find halite crystals or gypsum, because the lake is more near the freshwater condition because of the amount of fresh water introduced into the lake. So going upward to see some final picture of this the Rayoso Formation from this is some very beautiful sedimentary structures here with a lot of claiming ripples, planar lamination, massive sandstones, and on top, if you go into the drone view, from this position we can have a very general view of the upper part of the Rayoso Formation with the R2 sequence, the clastic interval, the transgressive system tract here, and the regressive system tract with this evaporites we have in this upper section, with the gypsum levels and also some stromatolites. Okay, now we are going into to see some example from the Yanchang Formation in China. The Yanchang Formation was accumulated in a continental foreland basin, a very unusual situation, but at the same time very interesting, because during the middle late Triassic in central China we have this very big basin, elongated basin, and this basin is going to show a complete record of lacustrine deposition from the beginning as an underfill lake, then going into a balanced fill lake, and finally an overfill lake. Here you can see a stratigraphic column of the Yanchang Formation. We can have more than one, in some places up to 1,000 meters, and at the beginning the sedimentation starts with the underfill, a lake in underfill condition, so the depositional succession will be this finding upward, then we go into balanced field condition, and at the end we go into a overfill condition. So we are going to review in some detail, step by step. This is the initial accumulation in underfill condition, and as you can see here, this is a typical small depositional sequences in the Yanchang Formation. In the lower part, you have this finding upward succession that forms because of the transgression, the lake transgression, and at the end you have this very sharp, in sharp boundary you have this red bed, thin level of red bed representing the regressive system tract, in which we have this soil with some caliche nodules and all the stuff, typically of a at lake level fall. So this lake level continues to rise up to the top of the maximum level when the Yanchang Formation is going to reach the spill point. So this is the typical deposits of the Yanchang Formation. Here you have some lobes with red beds on top, marking this lake level fall at the top. And the deposits are basically accumulated by hyperpygnal flow in the different kind of channels and lobes. So when we go into the balance field condition, it's very interesting because the lake is going to reach the spill point, and at some point is going to breach this spill point, and the lake level is going to fall some meters here. So this is the typical situation of the accumulation in a balance field condition. You have initially an accumulation in an underfield condition. You have sedimentation, and at the same time a transgression. You have at the same time a rising lake level. Then when the lake level reach the spill point, the sediment start to prograde, start to form these clinoforms here with deltas, very well extended deltas. And at the end, when the sediment supply stop, according due to the subsidence, the lake and the evaporation, the lake level fall, and you have the development of these soils at top of this small sequence. This is the typical accumulation during the balance field interval. At the bottom you have this finding upward succession accumulated during the underfield condition, and then this progradational part with the progradational delta system related to the RST during the overfield condition of the lake. This is a particular situation that happened when the lake reached the spill point. When the lake reached the spill point, the lake is going to breach here the spill point. You are going to have this incised canyon here, and at the same time the fluvial channels is going to carve this incised valley. The typical deposit of this incised valley we can recognize on top of the chunk 7 when the lake reached the spill point, and this is the very impressive incisions in delta deposit related to this collapse, to this breaching of the spill point. And at the end, in the upper mega sequence, the lake reached the maximum level, and this level is nearly constant. So all the sediment supplied to the basin is going to build this progradational system, and so we are going to have these deltas, prograding deltas, according to the sediment supply. The typical succession of these progradational deltas during the overfill condition will be this kind of quartzening upward succession related to deltas accumulated in an overfill condition of this lake. This is a photograph showing the characteristics, some characteristic of this small scale delta deposit, in which you can see clearly the phase changes between a delta from and pro-delta in very short distance, because the condition, probably the condition of this lake, was a freshwater lake. Freshwater, typically the all overfill lakes are poorly freshwater lakes. And another discussion about this kind of deltas is very interesting, because this delta usually make this kind of accommodation, they manage the accommodation space, and you can find this switching in of littoral deltas in very shallow areas of these lakes. Another interesting point is that the change, the onset from underfill to overfill, you can recognize this in seismic, because this is typically, for example, chunk 10 to chunk 7, the deposition is more or less a gradational. But after chance 7, you can recognize these clinoforms. This clinoforms means that the lake level reached the spill point. So we can recognize the transition in many basins from underfill to overfill lakes just looking in detail the seismic. When the progradation of the low angle large scale progradation appears, means we are in overfill condition in our lake. This is another picture of the seismic and interpretation of Ordos Basin, and as you can see here, the progradation you have here suggests that the lake is in overfill condition. So the excess of water is drained out, so the sediment are able to prograde. Okay, some conclusion of this speech. So, sequence stratigraphy in lacustrine systems are largely much more complex than marine sequence stratigraphy. This is probably because we have another additional parameters that control the stacking pattern and controls the accommodation space. We can recognize in lacustrine system basically two system tracks. Transgressive system track and regressive system track. These system tracks are largely much more simple than the system track we recognize in marine system, for example, low stand system track, transgressive, high stand system track, and falling stage system track. And the accommodation space, for example, it's very important to understand that in underfill lake, the accommodation space is controlled by water supply. In balanced field lakes, the accommodation is controlled by water supply and the subsidence. And finally, in overfill lake, the accommodation space is controlled by subsidence. Then, many lakes show a complete underfill overfill evolution in the deposit. A critical point in the onset from underfill overfill is the breaching of the spill point. And this change from underfill to overfill condition can be also recognized in seismic by the presence of large-scale progradation. So, thank you very much again for this opportunity.